Hi, in this video I'll teach you a procedure through which you can find the inverse of an invertible matrix. This method will use the row reduction to row echelon form, and if you do it you will see if a matrix is invertible or not. You can decide based on this if it is invertible or not. Let us start. What is this procedure? Let A be a square matrix of order n. So it is n by n square matrix. Then step 1, form an augmented matrix So usually what we have for augmented matrices, we have A on the left, on the right you have one column. Here you put the whole identity matrix of order n. So if you started with n by n matrix, at the end you will have n rows, 2 n columns, because this is identity. It has n rows, n column itself. So you will have that thing. Step 2 is that, reduce this matrix to row echelon form. So reduce it to a row reduced echelon form. So it will be something like C and D at the end of the reduction, yes? Now, step 3 is where you have the whole, the decision. First, there are 2 cases. If the C, the left side of the matrix after reduction, is identity, then A is invertible. And what you know here is that then A inverse also is there. What you have on the right hand side is D. So in other words, for the invertible matrices, you start with AI, you row reduce it, it will turn to identity and A inverse. That's what it means. Okay? But if C is not identity, then A is not invertible, and you don't need to find the inverse of the matrix. It's not invertible at all, yes? This procedure, if you do apply all the steps, you will not only see if matrix is invertible or not, you will also be able to find the inverse for the invertible matrices. But if you're just looking for an answer for if the matrix is invertible or not, you can just use this fact that if row reduced echelon form of A is identity, then matrix A is invertible. This is actually if and only if matrix is invertible, row reduced echelon form is going to be identity, and if row reduced echelon form of A is identity, then the matrix is invertible. Okay, let's do examples, and in examples everything will be better, more clear. Example, find the inverse of the given matrix if it is invertible. Okay, the first matrix A is 1, 2, 1, 3. Let's do this one. Step 1, form AI. This is 2 by 2 matrix, so you put A to the left of this line, and to the right you put identity. Identity in this case is identity 2 by 2 identity matrix. So this is 1 0 0 1. Okay, so this is step 1. Now start row reducing this thing. So we will do apply. So I choose this one and make, well, this is in right place, good number. Let me put it in the box as I always do. So it is the leading one in the right place. It's 1 and everything's good. Now we have to make this guy 0. What do? We just use the row 1 and then make row 2, the first entry of row 2 0 by subtracting row 1 from row 2. So 1 2 1 0. This is 0. This is 1. This is -1. This is 1. Very nice. We are done with the first leading one. Now for the second one, we start here, move, stop when you hit a non-zero entry. It is 1. It is in the right place. So it is next leading one. Now we have to make everything else in that column 0. So what do we do here? We multiply row 2, the row with the leading 1, by negative of the entry, then add it to row 1. So this will be 0 1, -1 1. Here will be 1. This will be 0. -1 times -2 is 2. This is 3, and this is -2. Now you see that this is row reduced echelon form. Yes, and now go back and check the cases. Is the right hand side, this part, identity matrix? Yes, it is 1 0 0 1. Then that means that A is invertible, and we also find the inverse of the matrix. What is the inverse? The matrix on the right hand side of the row reduced echelon form is the inverse of the matrix. You can check it. You can multiply 1 2 1 3 to 3 -2 -1 1. Yes, this must be identity. So 1, this is 3 minus 2. This is -2 plus 2. And then this is 3 minus 3. And this guy here is -2 plus 3, which is identity. You multiply the other way around, you will get again identity. This shows that, okay, we have done good job. We confirmed that the matrix is invertible. We found the inverse, and we can also double check to see if we found the right one or not. Okay, so let's do one more example. Example 2. This time matrix A is a 3 by 3 matrix. Wow, this is nice. 0 1 -1 2 1 1. So we want to check if this is invertible or not. If it is invertible, find its inverse. We start with the matrix 1 0 1 0 1 -1 2 1 1, augmented by the identity matrix. Here the identity matrix has 3 rows, 3 columns. Remember what is the identity matrix? And this will be here on the right hand side. So this is step 1. Then let's just start making the reducing the matrix. So this guy here, this is 1. I choose it. It's in the right place. Now we can use that to make this one disappear. So multiply row 1 by negative of that and add it to row 3. This will be 1 0 0 0 1 -1 0 1 0. Here this is 0. This is 1. This is 1 minus 2 is -1. And this is negative 2. And what is this guy? Here is, well, 0, and this is 1. Very nice. Now we are done with the first row. Move from left to right, and then you stop when you hit a non-zero entry. I choose this one to be my leading one. It is 1. It's in a nice place, so I'll use that as my next leading one. Make everything else in that column 0. This guy is already 0. I'll make this one 0 by subtracting row 2 from row 3 and replacing it into row 3. So 1 0 1 1 0 0 0 1 negative 1 0 1 0. This is 0 0 0 negative 2 negative 1 and 1. The second row is done. Now we move to the third. Well, there is nothing here. All of them are 0, so it's done. It's row echelon form, row reduce echelon form. So this is row reduce echelon form. Now it's time to decide if the matrix is invertible or not. Look at the left-hand side of this. Look at the left-hand side. Is it identity matrix? Well, it is not. Identity matrix is 1 1 1 0 0 0 1 0 0 0 1. Here I have 1 0 1. This is not identity matrix. So row reduced echelon form of A is not the identity matrix. What does it mean for us? So it means that we are in this case 2. It means that A is not invertible. It's not invertible. Well, our procedure is a good procedure. Not only gives us the inverse, it also tells us when it is not invertible. Yeah. Okay, so this is a procedure you have to learn, and you have to be able to use it to find if a matrix is invertible or not.